Today we're going to talk about converting from one unit of measurement to another unit of measurement. Most of the world uses what's called the metric system, and we use this in science a lot. So whenever you're measuring liquids in science, you use meters and liters and milliliters. If we're measuring distance in metric, we use things like millimeters, centimeters, meters, kilometers. And if we're weighing things in metric, we use things like grams, milligrams, kilograms. But in America, for everything else, we use what's called the customary system. The numbers are not nearly as nice. They're all kind of random. But the good news is you don't have to memorize those numbers because you're given those on this chart. This part is all from the star chart. So this should look familiar to you from 5th grade. We're going to be using the box to solve these problems. So if you've been feeling comfortable with the box, then that should be helpful for you. So we're going to look first at what would go here. And this part is the same as with the regular box. This is always going to be, these two boxes right here are always going to be for your labels, which is the units of measurement that the problem is talking about. So if the problem's talking about feet and inches, then your labels would be feet and inches. Or if it's talking about liters and milliliters, then your labels would be liters and milliliters. And this middle section here, this is different from the regular box. So in the regular box problems, they give you 3 numbers. In these problems, they're only going to be giving you 1 number. And so the 2 numbers right here are going to be your conversion rate. We always say that the rate or the ratio goes in those boxes. So this is the conversion rate. It is going to go there, but it's not usually going to be given to you in the problem. So where could we find that? Well, we just looked at all those conversion rates that are listed on the star chart. That's where you're going to be getting that information. So you get your conversion rate from the star chart. I really want you to remember that. So let's go ahead and write from chart. So if it's asking you about meters and centimeters, you're going to find on your chart where it talks about meters and centimeters, and you're going to use that conversion rate. Or if it's talking about liters and milliliters, you're going to find that conversion rate on your chart. We'll talk more about that in a minute. But let's talk about what's going to go in these last 2 sections of your box. So we said that there's 1 number from the problem. So that number from the problem is going to go in one of those boxes. So one of these is going to be the number from the problem. And where it goes, top or bottom, depends on what the label is. So you got to pay attention to your labels. And then the other box is going to stay open, just like in the regular box, because that's for your missing number. Eventually, it's going to be filled in, and that's going to be your answer. Okay, so like I said, all this will make a lot more sense if we look at some practice problems. So let's look at our first practice problem. It says Mr. Seville is mailing a large box that weighs 32 pounds. So there's the number they're giving us in the problem. The post office charges by the ounce to mail boxes. How much does the box weigh in ounces? So we're trying to go from pounds to ounces. So I'm going to draw myself a box. And again, those 2 units of measurement, whatever 2 units it's talking about in the problem, that's our 2 labels. And all of these have abbreviations on your star chart. So if you find pounds and ounces, you're going to see that the abbreviation for pounds is LB and the abbreviation for ounces is OZ. I want you to try to use those as much as possible. And then remember that you do not start with the number in the problem. You start with your conversion rate, which you find on the chart. And we just thought 1 pound equals 16 ounces. So 1 pound equals 16 ounces. Make sure you put them with the right label. Then we can put the 32 pounds where it goes. Once you have your numbers in the right spot, you're going to solve it just like the regular box. You're going to cover up your 2 diagonal numbers, so we know our arrow has to start with the 1. You can actually go either direction in this case, but I'm just going to go in the direction of our conversion rate. So 1 times 16 is 16. So we need to do 32 times 16 to give us our answer. So I don't know 32 times 16 off the top of my head. So I'm going to go ahead and do that math out to the side. 6 times 2 is 12. 6 times 3 is 18. Plus 1 is 19. Placeholder 0. 1 times 2 is 2. 1 times 3 is 3. When I add those together, I get 512. So 512 ounces is my answer, which is answer choice B. The next one says an office building floor has a perimeter of 5,550 feet. What is that perimeter in yards? So it kind of can confuse you if it's saying perimeter. Sometimes people think this is a perimeter problem, but it's not. It's telling us to go from feet to yards. And again, if I look at my chart, I'm getting those abbreviations from the chart. Yards is YD, feet is FT. And right here is my conversion rate. 1 yard equals 3 feet. 1 yard, notice I started with yard because that's what the 1 goes with, equals 3 feet. And then I can put the number from the problem, which was feet. So it goes by feet. If I cover up my diagonals, I know I need to start with 3. Now there is technically a relationship going this way, but I don't know what it is. So I would go this way because remember, we know that any number divided by itself is going to give us 1. So I can divide this number by 3 also. I have a matching arrow. And again, this is not something that I would do in my head. So I'm going to go off to the side and do that long division. 3 goes into 5 one time. 3 times 1 is 3. We subtract. We bring down. 3 goes into 25 8 times. That's 24. We subtract. We bring down. 3 goes into 15 5 times. That's 15. We subtract. Yes, it's a 0, but we're not done because we still need to bring down our last number, which is a 0. 3 goes into 0 0 times. So the answer is 1,850 yards, which is answer choice A. And we have one more problem. So this one can be a little bit confusing because we've got meters, we've got centimeters, and we've got millimeters. So basically they're giving you, it's like if I said I was 5 feet 5 inches tall. That is how tall I am, right? So this dog is 1 meter and 30 centimeters tall. We want that whole thing changed to millimeters. So the easiest way to do this is first figure out what this 1 meter is. So my chart here says that 1 meter is 100 centimeters. So this right here is 100 centimeters plus the 30 centimeters right here. So total, the dog is 130 centimeters. That's what we're trying to figure out, how many millimeters it is, right? So I'm going to go ahead and draw myself a box going from centimeters to millimeters. And again, cm and mm are the abbreviations that they use on the chart. So cm and mm. And the chart says that 1 centimeter is equal to 10 millimeters. And again, our dog Harry here is 130 centimeters. So we want to change that to millimeters. If I cover up my diagonals here, I know I have to start with the 1. I can do 1 times 10. So over here, I'm going to do 130 times 10. And if we multiply a whole number times 10, we just need to add a 0 on the end. So that would be 1,300, which is this answer choice right here. There's one more thing I want to show y'all that could help you on some of these problems with the metric system. And it's about moving your decimal point. So if you move your decimal point to the right 1 time, that's multiplying by 10. That's actually what we just did on that other number, because no decimal in sight, put it on the right. So if we're looking at 130, if we put a decimal on the right, if we move it over 1, we'd have to fill in a 0, which is how we got the 1,300. So If you were to do that twice, you'd be multiplying times 100. And if you did it 3 times, you'd be multiplying by 1,000. So that's an easy way to multiply by 10, 100, or 1,000, is just to move your decimal point. You can do the same thing for division, but you would go to the left. So if you move it 1 time to the left, you're dividing by 10. If you move it 2 times to the left, you're dividing by 100. And if you move it 3 times to the left, you're dividing by 1,000. That's a lot easier than, trying to do long division by 100 or long division by 1,000. Just remember, move your decimal point. And if there's no decimal point in sight, put it on the right. Hope that helps.